Hi folks, I'm Paul Richardson, and this is going to be an introduction to SMCC's Learning Lab Silly String Advanced Deployment Device. And we'll talk more about what that means here throughout this entire thing. Now, I'm not going to go through this like I'll do it with the students. With the students, this part of it's meant for middle school. We'll have a high school version of it also. It'll be 2 4-hour classes, and obviously I'm not doing all of that here, but I will go quickly through the entire project so you get a sense of what we'll do. Maybe talk a little bit about what you need as a middle school and the students that would probably be best suited for this. A better picture here of the by the way, they'll get all the parts that you're seeing here, so they get everything they need, and this is pretty much what their desktop will look like when they get it set up in a classroom. So all of this is assembled, but it'll all come boxed in a nice cinch sack that's labeled with the SMCC Learning Lab. And their idea is to, obviously they're going to assemble all of this, and they'll learn a lot of stuff. We wanted to integrate as much of STEM as we could into a single project, and we did a pretty good job with this. And then to make it, maybe even one step more difficult, we then add the idea of networking and how you're able to drive, the silly string device or get information back from the Arduino live over a web page. Now, middle school students aren't going to have to obviously write any code, although they will write a little bit, so they'll make some changes to files and things like that. But they will absolutely wire everything up, unbox everything, get it all together, load the code. So load up the code on the Arduino, load up and run the web server code on the Raspberry Pi and get them talking to each other. And when all is said and done, they'll have a nice little web page of their own where they can get data from the Arduino or send data to the Arduino to launch the silly string. Here's a better slide. I did a presentation of this recently to our advisory board, and this kind of gives the idea of what the students will be doing. So a student can pull up a web page. They can make a call to their web server. So their web server would be, let's say, sitting in their house, right? Their Raspberry Pi that they will get. Then the Raspberry Pi can send information to their Arduino, which would be sitting connected to the Raspberry Pi, and then that can send information to the silly string to launch it. Or it could send information for the high school students to a robotic arm to start moving the robotic arm. Now, data can also be sent in real time the other way. So they'll have a temp sensor and a distance sensor, which sends data in real time through the same pipeline to the web page. And the nice thing is, they have this system now, and then they can do whatever they want with it. So they could scrap the robotic arm or the silly string and put other devices on here. And I'll also give them more videos. I've got plenty of videos, and maybe it's that they want a sound sensor here, and I've got a great video on that. And I say it's great because my one of my pups makes a cameo in it, which is kind of funny. But there's a sound sensor, and this detects the sound. We then process the sound and determine whether, let's say, the smoke detector is going off, and then in real time we could send a push notification, or maybe an end user has a wearable device, and if they're hearing impaired, then it vibrates in real time when the smoke detector goes off, or somebody knocks at the door, or what have you. We have a past student that runs their egg farm this way with solar and wind power, and uses the backbone of this system to monitor and actuate devices on that farm, and they can do that from anywhere as long as there's an internet connection. That's the same thing that the students would do here. Here's the devices being printed at school. So we've got 6 printers, and if you kind of, I don't know if can we zoom in there a little bit? You can, right? And you can see that the devices are going. It takes about 16 hours to get one set printed. We need 150 of them, and Dan Abbott is fantastic, and he's been doing most of getting these all printed for us. So thank you very much to Dan. Not that I assume he'll watch this, but so those are going. I think we're about halfway there. We might have about 70 or so done over the last month or so. So we're getting there. The other thing too is the schools will come back around. Then eventually the schools will end up having a weather station set up. So they'll have a weather station. That weather station will gather data again in real time. It'll then push it up to a database that I have set up at school, and then I have another web page that's going to read that database in real time and present the student data. And that will be on this page right here. And the only one that's here right now is my house, just to, so I could get the code all up and working. There's a good amount of code for the front end and the back end, and obviously the remote applications that were feeding data to this, right? Reading that sensor data and feeding it. And it works the same basic way as their Silly String shooter. There's an Arduino. It's reading the data of the devices. It's sending it to the Raspberry Pi, and the Raspberry Pi is pushing it up to a cloud-based database that I have. And then the application on this side just reads that data. But again, students will have an apple all over the map, which is kind of cool for their middle school. And you'll be able to toggle between. This is just showing temp, but the rainfall or the wind speed or what else is on there. Humidity. So I guess that's it. Temp, humidity, rainfall, and wind speed would be the four things that they'll be able to toggle between. Okay, so let's jump out of this, and this will be fun. We'll do some stuff and learn a little bit with the students about how an anemometer works. So a little interest, a little bit of information on it. We won't get too much into detail, but they'll have a pretty good idea of what the math is and how we do those calculations. Okay, so we don't need this anymore. Let's jump back to this. This is what their desktop again will look like. It'll be all boxed up, and they'll have to assemble it all. Let me jump down. Let's see here. So as we go through, right, we're going to do this. It'll be all done in chunks, right? So we'll start with the Arduino side of, well, I shouldn't say that. I'm showing the Raspberry Pi. They have to get their Raspberry Pi up and running because it's the computer that they'll use in the classroom. So what do we need on your end? Well, on your end, then the only thing we really need is the students in a room. I will bring everything else. So they will have their computer, which they get to take home, and it will be the Raspberry Pi inside of a keyboard, which is called the Pi 400. So it's this one right here. So I've got one right here. So this is the Raspberry Pi computer. It just happens to be in a keyboard, and it comes with a mouse and such. So they got a little computer they'll be able to take home, and they take all of this stuff home except for the monitors. So I'll also bring small monitors that they can use in class. They don't need an internet connection. I will bring a overhead projector. I'll bring the screen. Again, the only thing they will need is a room, desks, and a place for me to put. I'll even bring my own lectern. Now, if you're remote, if I'm doing this and you're 6 hours away in northern Maine, that's going to be a little bit different because there's going to be need to the students will need to be in a room, but there will be a need to have a projector where I can be doing exactly what I'm doing here. And the nice thing is the students they'll all be in the same room. So I was going to say students can all see each other when they log in via Zoom to my lectures this way, but they'll all be together in a room, so we don't have to worry about that. But you'll need an internet connection, obviously, and a screen and such, so the students can see me, and then folks in the room to help the kids, since I won't be there. Even if I'm gonna be there, then it's helpful to at least have one teacher in the room to help out. Okay, so we'll go through step by step. They'll get their computer up and running. We'll talk a little bit about what a Raspberry Pi, what a Linux system is, and it's very similar to a Mac or a PC that they may have used. Excuse me. And then take a look here. This is eventually the website that they will have. Now they'll rename it from Name Me Please to whatever they want to call it. And there's really two parts. One is they can send a signal to the Raspberry Pi and then to the Arduino to launch the Silly String. And then the other is in real time they get data from the Arduino with the distance and the current temp. All right, so we've got two-way communication in real time behind the scenes. It's using something called WebSockets. We won't talk about that with the middle school students. In the big picture we will, but the high school students will understand this stuff or start coding this stuff a little bit in detail. Now again, I'm not going to go through all the steps that I'll go through, but these are the slides that we'll go through in lecture, and then eventually we get to the Arduino and we'll start going. We'll talk just a little bit about the Arduino and what we're looking at here. Now, the setup that I have looks like this. I use straight wires to connect my Arduino to the breadboard here, and it's just so it's easier for the students to see. If when I'm doing this, even if I'm in class, I'll have a document camera where the students will be able to see this on the screen. They will have jumper wires like this. It's the same connections. These are just made to be able to hook up anything. These are cut purposely for this. But this is what they'll end up with. And then we'll do baby steps, right? So we'll start and we'll connect power. So we'll bring power over to the Arduino. And any place there's a hands-on, I've got a little hands-on up here. Then we'll hook up the temp sensor. So we'll get the temp sensor connected, and they'll be at this point. And then we'll load up and run code. Now, while we're here, we'll probably talk a little bit about serial communication and what serial communication is, because the Raspberry Pi and the Arduino have to talk over a serial cable. So they'll get a little bit of an understanding of what that means. And then finally, they'll get to load up some code, right? So let's actually do that part so you can see it here. And let me close this. And here is the desktop that they will be looking at. So again, this is their computer. They end up leaving. They take it home. The only thing they won't have is the monitor, but they can use any monitor. They could plug this thing into their TV. Okay, so they'll open up the Arduino editor. I'm also going to give them projects they can take home and do at home too. So some things that they can kind of keep learning with this when they leave. So they'll open up the first code. And everything's all set. Again, they don't need an internet connection. They don't need to go get this code, although I have it all up on GitHub if anybody else wants it. They'll have to maybe just do a quick check, and we'll do it in class together to make sure that the board is Arduino Uno, but it will be because I've got this image, right? Everyone will have an image that I have fully prepared, right? The Linux image. And then the port is going to be the port that their Arduino is plugged into. And again, now the Arduino, just to be clear here, if we go back here, right, the Arduino, this serial cable runs to my Raspberry Pi. Now, I don't have a Pi 400 here, just because it was easier just to have a regular old Raspberry Pi and have a keyboard plugged into it, just to make my life simpler, right? Theirs won't be this one. It'll be that inside of the keyboard. All right. Straighten that out now so it doesn't bug me. Okay, cool. So let's come back here. And that's what I'm talking about, right? What port this is connected to on their Raspberry Pi. And again, that's where we are, right? We are on the Raspberry Pi right now. Okay, so two things they can do. They can first just verify that the code is fine, and it will be. And then they can load it up to their Arduino. So now they're pushing this code to the Arduino. They're viewing it over their Raspberry Pi. That's the computer that they're using. And once they're done, they can choose the serial monitor, and it'll be in a loop. It'll actually tell them what the current temp is. Now, it's going to change much because, well, your temperature would have to change, but eventually it would change. And again, eventually they'll be able to see this data in real time any place they have an internet connection. Okay, so that would be the first step. And if just to point that out here, let's go. Oops, no, I don't want to go here. That's this sensor right here, right? So that's that temp sensor, and again, that's all they would have hooked up at first, right? Just to make it relatively easy to do. And I'll come around the room. Somebody will come with me. You'll have somebody in the room, and I'll also zoom in, so I can zoom in on this even when I'm in the room. So I'm a little bit closer with the connections, and they can see what goes to what. So it'll be nice and clear. Okay. So the next thing will be we would test the distance sensor, right? So we go through and do the connection for the distance sensor, and I guess I should have done that while I was here, but that's this sensor right here. And we can talk a little bit about sound waves and how sound waves work, the speed of sound, but really one of these sends out a sound, right? A trigger sends out a sound wave. There is an echo. The echo comes back again. It went out. It came back at the speed of sound. Well, based off of that, we can figure out how far away something is. And this will go up to, I think, about 10 feet or so. So, it's pretty accurate. Not bad for, relatively, inexpensive sound detector. Okay. So we can do that. And here, let me do this. And let me grab my test box French Bulldog grabbed it. I dropped it, and she was having a party with it. But I just used this to put in front of my distance sensor here. Okay, so we would then load that code up after we, again, talked a little bit about sound, and they wired it up and such. So they can open up, and that would be the ultrasonic. Once again, all they have to do is load it. So, and we'll talk. Probably won't talk too much about this code. There's a little bit going on here. The high school students will talk a lot about it, and I'm going to actually have them write a lot of this code, so I won't can as much of it for them as I'm doing here. So they can load that up, and then once again, they can go to the serial monitor, and this is pushing serial data out. So I'm writing serial data out, which eventually I'll grab again on the Raspberry Pi. But right now, let's just look, and you can see, and what I'm doing here is I'm just moving the, here we can minimize this here. I'm just using a tool called VNC Viewer to be able to get to my desktop on my Raspberry Pi from my PC, just to make it easier to only not have so many devices here on my desk. So now we could come here. Let me minimize this. Bring this over here. Cool. And again, all I'm doing here is just moving this. Right? You can get a little bit closer, right? And you can see, and then we can start pulling that away, and we can get some distance in inches. Although, here, hold on. I'm like, that doesn't look good. If you look at it here at first, I'm like, what the heck happened to my code? We forgot the decimal in the whole number. So there you go. You can see as you move this, and we keep kind of going back, and we can get pretty far back. Okay, cool. So they would go through that process and see that that is working, and then lastly, right, the fun part is, well, let's get the servo working. So first, we will just hook up the servo. At that point. I wanted to go to here. So at that point, we've gone through all of this, and we've talked about the distance. Took a little time to get I did that in 3ds Max to get the animation of my sound wave. Let's see here. And if we come down, now we're talking about the servos. And at this point, everything is connected because we did the temp in isolation, we did the ultrasonic sensor in isolation, and now we hook up our servo motor. And we can then just test that out in isolation, the same thing. So we go through, we'll test it out. We'll talk a little bit about the different types of, we do that here. So there are 180-degree servos. There are continuous rotation servos that you'd use for a robotic vehicle or something like that. Rover on Mars, and then drive it remotely. Same basic idea. Let's see here. And then here's all the parts, right? So we'll show them the parts. This is what they're going to end up with, right? We'll show them parts, and then we'll collectively put it together, right? We've got to put the screws in and go through that entire process. And instead of making this video so long, you don't need to see me do this, but again, we will do all of it in class. So they'll get it all together, right? Go through. There's a finished nail that holds the trigger to the cap, right? Thank you, Dan. Dan spent a lot of time refining this to get it so it's really easy to print, although it takes, again, about 16 hours to print one, but you can print it on any type of 3D printer. So we've done it on about $180 printers, and we did it on a $30,000 printer. Actually, some cases it does better on the less expensive printers. Those ones you saw earlier, those are only about $450 each, right? So Creator Pro 2 is the type. It's a great printer, and if you need to do 3D printing, think about something like that before you spend a whole bunch of money, right? So Creator Pro 2, and again, they're about $450, and they're awesome. They've been relatively flawless as we've been printing these. And then, we'll talk about calibration, how we actually calibrate this to, the servo's got a swing. It's going to be off the trigger of the can, the button for the can, and then that trigger will come down and push the actual can, the button down. And how do we go through a little bit of a calibrations and just talk about maybe what calibration is, right? Making adjustments based off some standard. We want it to be firing. We don't want it to be firing. And this is where it gets a little messy. So I'll bring a bunch of empty cans because I've done this before with a live can, and there's silly string everywhere in my office, outside my office. There's a printer outside my office that was covered in silly string for a long time until they replaced it. Not because I put silly string on it per se at all, but it wore out. Okay. And then, you know, we'll come down and we'll get it calibrated, and then finally it's going to be, you know, they'll get to the point where, you know, the rubber bands are what hold the cap down, right? So when you push down on this, the top just doesn't go up, so the rubber band holds it down. We can talk a little bit about the design and such too. And then, you know, after we get to that point, then it's time to actually talk about the code that's going to run on the Raspberry Pi, and that's going to be the web server and the WebSocket API that's going to run. It's going to get that data in real time, and it's also going to display the web page. So we'll get to the point, and we'll go through all of that. And they'll actually make some changes, so we'll get to the point where they will change the name, right? So instead of everybody having it called Name Me Please, they'll eventually make some changes to the code. And again, I'll do all of this live. So these are just kind of the notes that I'll have as I go through class. Although I sent this file to a 13-year-old about 2 weeks ago and his father. Neither one of them are, you know, they're very bright, but neither one of them are super techie. And they got through this fine. They actually didn't ask me any questions. Although the 13-year-old sent me a great write-up on how I could make this PowerPoint better, and it was amazing. Anyway, so then eventually they'll change the name, and now you can see I renamed mine Superstar Problem Solver, and folks, that's what we're trying to create here. Not only create problem solvers, I mean, any one of these in isolation, right? So if you take any STEM or anything that we're doing here, right? Programming, electronics, networking, all of them are difficult by themselves, but never mind putting them all together, and then put them all together and then have to run them and test them over a network so you can remotely monitor and run them. It's pretty amazing. And like I said, I've seen, you know, 11 and 12-year-olds do it in a room multiple times, so I know it's possible. And, you know, it's great because they'll help each other. If somebody's struggling, there's always someone in the room. And then the best thing is they can then take this and do something else with it. And, you know, who knows, you know, maybe one of them's going to be the next person that's working on, you know, remote surgery devices and things like that. And that's it. You know, we'll get to the end. And what I'll do is I'll put one together. I've got one together. I'll hook it up when I'm done. I'll stop this and then I'll put it on the end here so you don't have to watch me put it together, just so you can see it launch, because it wouldn't be a lot of fun having to listen to me yak on for, you know, a half hour here and then not see it launch in the end. The only thing we are not going to do, so they'll have a web page. They can pull up their web page, but they'll only be able to pull it up locally. So the web page, they'll have to be on their Raspberry Pi to pull up the web page. Now, it doesn't take a lot to go from there to be able to pull it up anywhere on the planet that has an internet connection. But we just didn't think that would be a good idea to do with the young students. So instead, what I will do is I will have a video at the end of this for parents. And what they can do is they can go through that process with their child when they get home. And it won't take long. I mean, it's simple to do. I'll have it all set up. They just basically need to create an account and run one script. And now the student will have a web page where they can pull up and actuate and monitor their temp and distance sensors anywhere on the planet. And the other thing is, I also have open Zoom lectures every Thursday night. So the parents can stop in if they're having any trouble or something. They could always stop in and ask for help if they're trying to get that so it's available on the internet. Okay, so hopefully I wasn't too long-winded here, although I'm sure I was. I'll stop this. I'll put this together quick. It'll only take me a couple minutes. Not that it matters, because I'm going to splice it on, and you won't know how long it was. And then I'll come back and I'll show you the finished product here. Okay. Okay, folks, so I have it all connected here, and before we would move to the web server side on the Raspberry Pi, we'd want to do a test here. And again, keep testing everything in isolation, right? We test the temp sensor, test the distance sensor, test the servo in isolation, then hook it up and now test it with it all connected and ready to launch your silly string. So what I can do is, this code is all loaded up. We come over here. Serial monitor. Oop, there we go. Did I open multiple? I didn't. So I come to the serial monitor, and you'll see that the serial monitor is pushing data out to us. So we're getting the data. And I've got, I should probably stop moving in front of it. Let me put something in front of it. There we go. What you're going to notice is I have the code set up so it only changes, I think, every, zero point 0.2 inches or something, or same thing, every half a degree it'll update instead of just constantly sending data. Not that it mattered, right? I mean, if you needed to send data in real time constantly, again, real time's a relative term here, but constantly, then you could. But for this purpose, it'll only, I think I set it to be like 0.2 inches or something like that, or half a degree that it'll send the data. Okay. So, and then the more importantly, we can also not only listen for data, right? We can send data. So we can send the signal launch. It can only be launch. It's got to be in lowercase. This is Linux. You can't just willy-nilly choose your case. It's listening for lowercase launch. And now we can launch this. And when I first started doing this, got this whole thing set up and getting ready for the first class, and my office was just covered in silly string, and it was adorable back then. Now it's not so much adorable. All right, especially at my home office. So let's launch, and there we go. Right, so we launch it, and a nice pile of silly string here. Okay, so that works great. So we know it works here. So let's kill the serial monitor on this side. Now we can't leave it open because we can only pull that serial data from one place. Now we can just close the Arduino editor too. Now what we want is we want to open up the code, or get the code running on the Raspberry Pi. So then we'll open Visual Studio Code. So we'll open that up. Oh yeah, by the way, your classroom's going to be a mess, so kind of prepare for that. Now the good part is you don't have to have a room with your computers in it. It's their computer. Although I guess it's our monitors, but that'll be all right. We'll clean them off, hopefully point them in a direction that maybe you want to supply a little Tupperware container like I did to the kids. Okay, so here's the code. Now I'll talk a little bit about the code, but we're not going to talk too much about what happens here. And the only thing they're really going to have to do is run it. Now we can also set it up, and I probably will. I'll have it set up so it can also run automatically, or even better, I'm going to create a video at the end so the parent and parents and the student can expose their server to the world, right, to the internet, and at the same time I'll show them how to set this up so it runs automatically. It's just a couple lines of code you have to run at the terminal. They'll even be able to just paste it in, so I'll give them the lines to run. But okay, so now it's just a matter of Node. If you're going to run it by hand, app.js. And voila, it's going to open up or start up a web page, the public side, and then a server on the back end that's kind of listening for data from that web page. All right, so let's go to localhost 3000. You can just hold down Control and open up a web browser here. And now they've got their web page. So they have a web page, and let's minimize this. Oops, I need to minimize it that much. Let's try that. Let's try that again. Let's do this. Cool. Let's bring this over here. That's better. Okay. And obviously, again, more. Well, let's do this. I guess for kicks, right? We can change the distance. And again, it looks like it's changing a little chunky, but it's only changing because it looks like I'm doing every point. Whatever it is, like half inch or something like that, maybe. So somewhere in there. But again, it could just be real-time update all the time. And obviously the fun part now is what this will do is it'll send that same string of launch in serial, but then convert it. And voila, you can click that button and you can see how pretty quick it is, right? So it's relatively quick. Now that's great, but the only thing that stinks right now is they would have to be at their Raspberry Pi to do it. And how much? That's not a lot of fun. So, well, it is fun. What am I saying? But wouldn't it be even cooler if we did this? So let's get out of here. Right here. Okay. So I will and I'll show you guys how to do this. Again, well, it'll be for the parents, but I'll send a video home with the so the parents can do this with the student. But all you need to do is log in with a email address, and I had an account from my developer in my school, so I just used this email address here. And what it'll do is it'll give you just a line that you have to run. So what this is going to do is it's going to add a virtual machine or a private virtual network, basically, so you can tunnel into your Raspberry Pi from anywhere safely. All right, so let's copy this. And then all you need to do, well, they will need to do is they can just run this at a terminal. Now, they kill the server. We'll talk about this whole thing. And again, they're going to make changes to it and stuff, right? You know, one of the basic things they'll do is they're going to go and we'll talk a little bit about CSS and JavaScript, and it's fun. It's a fun class to do, and index.html. But they can go and they can name it to something else, right? So you can see it says "name me, please," and they can name it to whatever the heck they want, right? So some name. It's not very creative sometimes. All right, we'll give that a save. Now, before we start our server back up again, we can run. I'm going to paste this in here, and it's going to get that virtual network up and running for us, so we can then have a public web address to get to our Raspberry Pi. Now, I guess my bad. There's one other thing that that you'll have to do here, and that's going to take a second, but it's not really a lot of seconds. So you know, it's again, this we won't do with the this we won't end up doing with the students. This will be only for the parents, and again, it's not overly difficult to do. But I'll just do it here. Skip over it if you don't want to see it. You probably won't. Cool. Okay. So here's where we have to go through. We'll have to install Nginx to get this to work, right? So I think I can run all of those at once. I don't know if I set it up exactly the way that it would work, but let's find out. So what this is going to do is it's going to listen, right? So this Nginx, it's a full web server. You can use it as a web server, or load balancer, reverse proxy, a whole bunch of cool stuff. You might be saying, I don't know what any of that is, nor do I care. The thing that will make sense here, though, is you're going to listen. Though it listens for traffic coming in on 80. Even better would be 443, but 80 for this purpose. And then what it'll do is it'll forward that internet address to your Raspberry Pi, right? So the your Raspberry Pi runs on, or their Raspberry Pi will be running on port 3000. So again, you might not care too much about that, but we can now come here, and I'm going to paste this in. We'll do a Control X, yes, Enter, right, and then we can come back here, and we can run these last two lines, and we have to create a link and then restart the server. So I want to be here. Paste. Cool. Okay. So now we can start Nginx. So we could test it, but let's say it's running. If that doesn't work, then I'll test it, make sure it's running. But now we can do node app.js again. And here should be the coolest part. If we now say done, what we can do is we can turn on a wormhole. So we have, so now we have a link. It's kind of silly that I get this excited about this stuff, but especially when I also do this for a living with big machines. In addition to teaching full time. But now you can see this is a web page that really any of you could go to, but I'm not that dumb, and I'll have this shut down before you can spread silly string over my desk. But I'd at least try it if I were you, just in case I'm not that bright and I forget. Let's come over here, and let's come over, and I'll cut out some of the middle of that, just so you guys don't have to watch all of that. And now we want to go to, I wanted to go to here, right? So now you can see that, again, this is a web page. I'm not pulling it up locally. I'm going through the internet here. And once again, you can kind of see, right, the change in real time. And voila, and launch. Not so bad for just going over the public internet. That is a pretty good response time for this, right? So that's it. Hopefully it's helpful if you're considering doing this with your middle school, and I assume Brenda probably sent you a link to this. If you ever had any questions, it's P. Richardson at smccme.edu. Feel free to reach out. Feel free to reach out and send me any questions, and I'm more than happy to answer them.